Okay, so this is type 4 general solutions. This is how you'll identify it. You always have sine on one side, cos on the other side, well, different trig ratios on different sides, and the angles are different. All right, so different to type 2, I'm still talking to you. So different from type 2, in type 2 you have the angles being the same. Here the angles are different. That's how you always identify it. So the first thing you always do is try to make the trig ratios the same. So far we have cos on one side, sine on one side. The first thing you want to do is make them the same. So either change sine into cos or change this cos into sine. And this is how we do that. If you have sine and you want to make that a cos, you change it into cos and immediately put 90 degrees minus whatever angle you had. So that's the first thing I'll do here. I want to change the right hand side. I want to change this sine into cos. Let me bring down this side because I'm not simplifying that. So I want to change sine into cos. I'll make it a cos and immediately put 90 degrees minus whatever angle I have. And it has to go in a bracket because I put a minus and I'm about to put two terms. So those two terms have to go in a bracket. Then next, I will simplify this bracket by distributing negative inside. Still going to bring all of that down. Okay, I'll bring down my 90. I'm only distributing the negative. So that's minus 70 degrees plus x. Then we'll simplify further. These are like terms. So I'll bring that down. 20 plus x. Once you've simplified completely and your trig ratios are the same, we're now ready to take the key angle or reference angle depending on what school and what teacher. So in this case, and as a general rule, your key angle should always be the angle that you changed. The angle on the side that you changed. In my case, I changed the right hand side. So the angle on the right hand side is my key angle. So in this case, 20 degrees plus x, that's my key angle. Then we go to the quadrants. As usual, as normal general solution goes. After getting your key angle, you look for the quadrants. In this case, we want the quadrants where cos is positive. If you read this out, this is positive, cos is positive everywhere. We want the quadrants where cos is positive. And we know that that's the first quadrant and the fourth quadrant. In the first quadrant, we have theta as it is. Fourth quadrant, it's 360 minus theta. So quadrant 1. And again, how you started out on the left hand side, you put whatever angle you had on the left. 3x minus 10 degrees is equal to, and in quadrant 1, we put the angle as it is, 20 degrees plus x plus 360n, n element of integers, as normal general solution goes. Then we solve for x. All the x's on one side, all the numbers on one side, so this x to that side, it will be 3x minus x, which is 2x. 20 plus 10 degrees will be 30 degrees plus 360n, n element of integers. Then we solve further. We're solving for x, so divide by 2 throughout. You're going to get 15 plus 180n, n element of integers. Or quadrant 4. In quadrant 4, again, how you started, whatever angle you have on the left is what you put on the left. So 3x minus 10 degrees is equal to, and then in quadrant 4, we have 360 minus our key angle. Remember, the key angle is two terms here, so we need to put that in a bracket. 20 plus x plus 360n, n element of integers. Then you solve for x. I'll destroy the bracket first, take the x's to one side and all of that. 360 minus 20 minus x. Are you okay there, camera man? Anonymous. Okay, then take this to that side, you'll get 4x equals 360 minus, that will be 340 plus 10, that's 350 plus 360n, and we divide by 4, we're solving for x. Don't ask me what that is. Plus 90 NL into integer.